Okay, so let us discuss yung amplitude modulation. So first, let us define or recall the definition of modulation. And modulation is the process of transforming information from its original form to a form that is more suitable for transmission. So it is a process of placing the information signal or the baseband or the message signal on a carrier of a higher frequency. Because we all know that if we transmit a signal through a higher frequency, gamit ang higher frequency, mas mababa yung kanyang interference. So, let us define kung ano ba yung amplitude modulation. Okay, so amplitude modulation is the process of changing the amplitude of a relatively high frequency carrier in accordance with the amplitude of the modulating signal or information. So from the name itself, amplitude modulation. So nagbabago lang dito yung ating amplitude, whereas yung frequency and yung phase niya is constant. So in AM, the information is impressed onto the carrier in the form of amplitude changes. So this is a system of modulation wherein the amplitude of the carrier is made to vary according to the instantaneous amplitude of the modulating signal. Okay, so take note that the carrier frequency, yung frequency ng carrier natin is constant during the modulation, and yung nagbabago lang dito is its amplitude, which varies according to the amplitude of the modulating signal. So, nagre-remain yung frequency ng carrier natin. However, yung kanyang amplitude, fina-follow niya yung amplitude ng ating modulating signal. Okay, for example, this is your modulating or the information signal. Information or your modulating Okay, so this is your information or your modulating signal. Susunod naman, this is your high frequency carrier signal. Okay, so ito ngayon yung amplitude ng frequency signal mo, and this is its frequency. Ito naman ngayon yung information signal mo. So, sabi kanina, take note that the carrier frequency remains. So, ito lang yung frequency natin, hindi yan magbabago. We will follow the frequency of the carrier signal, and we will also, or the amplitude will also vary in accordance with the modulating signal. So, ito ngayon yung amplitude niya. So, ito ngayon yung ating modulated carrier, yung nasa loob. Okay. So, if you can see, yung frequency ng ating carrier signal is nag-remain. Yung amplitude ng ating modulated carrier, finalo niya yung amplitude ng ating information signal. So, if you interconnect the positive and the negative peaks of the carrier waveform, ayan, if you trace this one with an imaginary line, then you recreate the exact shape of the modulating information signal. So, if you can see, ito, if we trace yung peak values, peak positive and negative values ng ating modulated carrier, we can trace back yung ating information or modulating signal, which is this one. Okay? So, this imaginary line on the carrier waveform is known as the envelope. So, ang tawag dito ngayon is yung ating envelope. Okay. So, if we can see, this is just the same. This is the same waveform ng ating modulating signal. So, envelope yung tawag natin doon. So this figure here, ito, is a representation of an AM high frequency sine wave. Okay, so an AM modulator, so this is the system of the modulator. A nonlinear device with two input signals and a single output. Yung two input signals ng modulator natin is yung information signal natin, which is at low frequency, sine wave for example, and then yung carrier sine wave natin, which is of high frequency, tapos ang output niya will be the amplitude modulated signal. So there are certain reasons or some reasons why the amplitude modulation is widely used. So first, it is inexpensive, and second, low quality form of modulation that is used for broadcasting. So, yung AM kasi natin, it uses low frequency. So, pag low frequency yon, recalling yung relationship ng wavelength and frequency natin, when we have a lower frequency, yung wavelength natin is mas mahaba. So, yung distance na matatravel ng signal mo is mas mahaba. And, of course, yung relationship ng attenuation natin to signal, it is directly proportional. So, kapag mas malayo yung tinatravel ng signal mo, of course, more attenuation yung mangyayari. Kaya low quality form of modulation siya. However, yung mararating ng signal mo is mas malayo. So, the information that you want to impart will be disseminated widely. So, yun yung reasons why AM is widely used. So, these are some applications of amplitude modulation natin. So, commercial AM broadcasting band extends from 535 to 1,605 kilohertz. So, ito ngayon yung ginagamit ng AM radio stations. For commercial TV broadcasting naman, we have your low band, ultra-high frequency channels from 2 to 6 that uses 54 to 88 megahertz, this frequency range. For high band UHF channels 7 to 13, it uses 174 to 216 megahertz range of frequency. Also, this is AM is used for two-way communications such as the citizens band radio, which uses the frequency range 26,965 to 27,405 megahertz. So these are some applications na gumagamit ng amplitude modulation. So, AM frequency distribution. For the commercial amplitude modulation or AM broadcasting, yung ginagamit nyo na frequency range is, as stated kanina, it is from 531 kilohertz to 1,605 kilohertz. And in assigning a certain frequency range or certain bandwidth doon sa channel na gusto kong mag-tune in, the increment or the bandwidth will be 9 kilohertz per channel. So this is the frequency distribution for commercial AM broadcasting. For commercial TV broadcasting naman, we have channels 2 to 6. Yung ating low band UHF channels which uses 54 to 88 megahertz. Since we are using 54 to 88 megahertz, if we want to get yung increment or yung bandwidth niya per channel, we are going to consider the lower band frequency 53 and the higher band frequency 89. Okay? Kasi we will start at 54 and end at 88. So, kailangan natin si 53 and 89 to solve for the increment or the bandwidth. So, if we are going to subtract 89 minus 53, so, ito yung higher frequency mo, 89 minus 53, that will be equal to 6 megahertz. So, ito ngayon yung ating bandwidth for channels 2 to 6. Okay? So let's say this is channel 2. We'll start at 54 and then add tayo ng 6 megahertz as the bandwidth. So 54 to 60 megahertz will be the frequency range of our channel 2. For channel 3 naman, we have 60 to 66. For channel 4, we have 66 to 72 megahertz. And then for channel 5, we have 76 to 82 megahertz. And for channel 6, we have 82 to 88 megahertz. Now, bakit 72 to tapos yung sumunod na is 76? Saan ginagamit si 72 to 76 megahertz na hindi ginagamit sa broadcasting? Okay, so 72 to 76 megahertz is a frequency used in military communications. Okay, so kaya hindi siya pwedeng gamitin for broadcasting kasi naka-allot siya or naka-assign siya for military communications. Now, for the channels 14 to 83, okay, so we now know how to assign frequency ranges of different channels. Now, for 14 to 83, masyadong madami kung isa-isahin natin. Let's just try one. So, channel 23. Let's try to get the frequency range used to tune in channel 23. So, how do we solve for the lower band? How do we solve for the lower band? We use this formula 6n plus 386. This will be equal to the lower band frequency of channel 23. So, ano yung n? Yung n natin is the location or number of channels. Or the number of the channel. So, ano yung number ng channel natin? Anong channel yung hinahanap natin for this one? That is channel 23. So, yung n natin is 23. So, if we are going to solve for the lower band of channel 23, we have 6 times 23 plus 386. And this is equal to 6 times 23 is 138 plus 386. And this is equal to 524. So, ito ngayon yung lower band frequency ng channel 23 natin. So, for channel 23, frequency range will be 524 to 530 megahertz. Okay, so we still have yung 6 megahertz na bandwidth natin for commercial TV broadcasting using amplitude modulation. Time domain signals are the actual variation of voltage over time. So they are what you would see displayed on the screen of an oscilloscope. So as you know, AC signals can be represented mathematically by trigonometric functions. So how do we present an AC signal mathematically? So ginagamit natin yung expression na to. So we have your E C will be equal to EC sine omega C T. Okay? So, this will be your amplitude, si EC, and this is the instantaneous voltage. Now, for the general equation of the modulated signal, we use this formula or equation. This is equal to E A sine omega C T. So, yung E natin is the instantaneous voltage, yung A natin is the amplitude, yung omega natin is the angular velocity which is equal to 2 pi F. This is our angular velocity, 2 pi F. And then, ito si amplitude natin, amplitude of the waveform. And then, si E is the instantaneous voltage. Now, if we go back dito sa ating modulating signal, how do we represent this one mathematically? So, let's say, ito yung kanyang amplitude and let's tag it as EM. So, if we are going to get the instantaneous voltage expression of the modulating signal, we will have EM equal to your amplitude na si EM, sine, since this is sine wave, omega m t. So, yung omega m natin is the angular velocity, which is equal to, in this case, 2 pi f siya. So, ano yung frequency na gagamitin natin? Of course, the frequency of the modulating signal. So, this will be equal to 2 pi f of m. F sub m. So, that is the formula, or that is the equation of our modulating signal. Next natin is the carrier signal. So, how do we represent this one? So, gagamitin din natin yung mathematical representation of an AC signal. This is equal to EC, since carrier siya, and then tag natin si amplitude niya as capital E sub C, or EC. So, EC, sine, since this is a sine wave, omega C T. So, si omega C naman ngayon is 2 pi F sub C. So, yung frequency ng carrier signal natin. Now, ito, how do we represent si modulated signal natin into an equation? So, the zero reference line of the modulating signal coincides with the peak value of the unmodulated carrier. So, in general, the amplitude of the modulated carrier signal should be less than the amplitude of the carrier. So, dapat daw yung amplitude ng modulated signal mo must be less than the amplitude of the carrier signal. So, keep in mind that the peak value of the carrier is the reference point for the modulating signal. So, ito ngayon yung reference point ng ating modulating signal, yung peak value ng ating carrier, which is si EC. So, the modulating signal value adds to or subtracts from the peak value of the carrier. Okay? So, how do we get the amplitude of our modulating carrier? So, yung amplitude niya will be equal to kay EC sa peak amplitude ng ating carrier adds up to EM sa instantaneous value ng ating modulating signal. And if you're going to substitute yung equation ng ating EM, that will be equal to EC plus EM sine omega mt. Okay? So, ito ngayon yung amplitude ng ating modulating carrier. Now, ano yung formula or equation ng ating modulating signal, I should say? So, ano yung formula or equation ng ating modulating signal? So, since this is a sine wave and we follow yung frequency ng carrier signal natin, of course, we are going to use sine omega ct. Okay? So, since this is the amplitude and this is the general equation, we now have the equation for the modulated signal, which is equal to EC plus EM sine omega mt, which serves as the amplitude, and then we multiply it with your sine omega ct. So, ito na ngayon yung equation ng ating modulated signal.